Hello. We're going to talk about gravitational potential energy. And gravitational potential energy, you may have seen, is a type of energy, right? It's a type of potential energy, which you may have learned about potential energy. Somebody probably told you at some point that potential energy is energy that is stored, which is mostly true, right? So potential energy is energy that has the potential to do something, right? So something that has potential energy could eventually do work with that energy, for example. Okay. So in this case, we're talking about potential energy that's related to gravity, that's related to gravitational situations, right? So we're going to be dealing with the constant g. Remember that 9.8 meters per second squared, the acceleration of objects due to gravity near Earth, right? So that g value is different on different planets and near different objects and stuff, but we'll just say that near Earth, that's good. Okay. So here's what you need to know. There's actually a formula for calculating gravitational potential energy, and we just call it GPE, right? And that formula is you take the mass times the g constant times the height. Times the height. There we go. Now, the important thing about this is GPE is going to be a type of energy, and energy is measured in joules. Okay. And we know that a joule is equal to a Newton meter. We talked about that last time, right? And a while back, we learned that a Newton is equal to a kilogram times meter per second squared. Why am I showing you all of this? So that you can see that if you take the right units of meters or wow, of mass G and H height, you are going to end up with joules. Okay. So what this is telling us here is that if our mass is in kilograms, so let's take it together. So if mass is in kilograms times what's the unit for G? G's acceleration. Acceleration's in meters per second squared. We've been talking about that for months. Times what's the unit for height? Well, height's just a measure of, distance. Wow. Which is measured in meters, right? Kilograms times meters per second squared times meters. Okay? So, according to the calculation that, or according to the work that I did over here, if a Newton is a kilogram meter per second squared and you're multiplying it by another meter here, that means that a joule is equal to a kilogram meter squared per second squared. Okay. So let's take this whole thing through. Let's multiply this whole through. Kilograms times meters is meters squared. Okay. Per second squared. Hey, look, it's the same thing. So the units you need to use for mass, especially, are kilograms. Okay. You need to use kilograms and you need to use meters and meters per second squared, which this part should be pretty easy. It's the kilograms part that people frequently forget. Okay. So let's do some math, shall we? Let's do a really simple example. Here's a hill and here is a big boulder. Okay. And that boulder has a mass, let's say, of 10 kilograms. Okay. And let's say that the height is 100 meters. Okay. So if we want to know what is the GPE in the boulder, we'll call it GPE rock, is equal to the mass of the rock, which is, right, M times G times H. So the mass of the rock is 10 kilograms times what's G again? 9.8 meters per second squared times the height, which is 100 meters, right? So easy peasy, we multiply these things together. 10 times 100 is 1,000 times 9.8 is 9,800 kilograms meters squared per second squared equals our GPE. Now, we don't want to write it kilograms meters squared per second squared every time, so we can just write 9,800 joules like this, right? You could just abbreviate that capital J. I just wanted to spell it out for you because lots of you are seeing the word joule and going, hey, lol, right? So that's how you would solve the equation in a very simple case, right? So what about another problem here? So let's say that you are a person and that you are carrying a backpack. It's this big object right here, right? And we want to find out how much GPE is in your backpack. Well, it's full of all of your textbooks, right? Because we sent you home for remote learning and we said, take everything with you, right? So the mass of this is going to be pretty large. We'll call it 10 kilograms, which is a lot. Actually, you know what we should do? We should call it 1,000 grams because then we have to convert the units, right? So we'll call it 1,000 grams. And we know that it's in your like mid back area, right? So let's say that you're, I don't know, let's say that you're freakishly tall, actually. And so then we're going to call the height 2 meters. That means that the backpack is resting at 6 feet. So that means you're very tall. You'd be like 6'8" or something like that. So we'll just call it that. Okay. And what I'm asking you to do now is tell me how much energy is there in the backpack, right? All of this is a cut. All of this is a cut. All of this is a cut. This whole thing's a cut. Cut this whole thing. Okay. So let's say that you are a person and you are carrying a backpack. Okay. And your backpack's full of all of your textbooks because you brought it home after remote learning, or well, for remote learning. And so you need to carry your Chromebook and your textbooks and everything that was ever in your locker just in case you never come back to school. Okay, cool. So we know the mass of this is going to be big. So let's call it 1,000 grams, which means we're going to have to do what with our unit, right? We're going to have to convert it, right? And let's say that you were able to measure how much energy you had. So you know that your total GPE that's currently in your backpack is, I don't know, 20,000 joules. Okay. So what we need to find out then is how high up is your backpack on your back right now? We need to find that out. So hopefully this works out and you're not freakishly tall, but you could be a giant. We'll see. Okay. Now we're missing something, aren't we? If we look at the formula, GPE equals M times G times H. We have M, we have GPE. We know we're solving for H, but we're missing G, right? Do I need to give you G? I mean, I probably will always give you G, but remember that G on Earth is 9.8 meters per second squared. Always true on Earth. Okay. So let's plug in what we do have here. For M, we have 1,000 grams times G, 9.8 meters per second squared, times H, 20. Oop, nope, that's wrong. Times H equals 20,000 joules, right? That's what we do now. And we're solving for H. Now, did you pick out the problem? I made an error and I did it on purpose. Here's the error. I left 1,000 grams in here. Is that going to come out right? It's not. We need to convert this. 1,000 grams is equal to how many kilograms, you guys? We need to move the decimal place 3 to the right. It's 1 kilogram. Remember this. Kilo, kangaroos hopping down, mountains, grams, liters, meters, grams, liters. So we started here at grams. We need to go 1, 2, 3, right? It's 1,000 times. Kilograms are 1,000 times larger. So we need to move the decimal place 3 to the left. So we have 1 kilogram. So let's rewrite this equation. 20,000 joules equals 1 kilogram times 9.8 meters per second squared times H. Okay? Sir. Oh, that's what you get to see, I guess. All right. Oh, now we need to solve for H, don't we? Let's go back to the blue here. So we're solving for H. So we know that on one side we've got 9.8 basically, and on the other side we've got 20,000, right? So 20,000 divided by 9.8 will give us our height. Wow, you guys are going to be very, very tall. 20,000 divided by 9.8. Okay, amazing. Okay, so H, the height of your backpack is going to be at 2,040.8 meters. Okay, so maybe you're standing on an airplane that is rising or something. I don't know. The problem itself makes no sense. Or maybe your backpack is actually a jetpack. There we go. It's a jetpack. There we go. So now you're 2,040.8 meters off the ground. Okay. And we calculated that using our big brains. Okay, sweet. So you've basically seen all the possible ways that this could work for you. I hope that this gives you kind of a breakdown of how this works. Remember, this is one type of energy, specifically one type of potential energy. All right. Good luck with the problems.